My name is Pinjarkar and I'm working here as a lead for this project as considering the software development part. So basically, this is how the user interface of the shipping radiated tool will look like. Basically, tool is divided into two components, majorly in instantaneous noise mapping and cumulative noise mapping. So at the top right corner, you can see that you can toggle between those two components. So first, we will go ahead with the instantaneous noise mapping. So instantaneous noise mapping gives the real-time ship rated noise mapping based on the current vessel's traffic. Uh, so in that, on the left side, you can see that there is a feature to add a AIS layer and bathymetry layer. So when we add the AIS layer, so current vessel traffic will be popping up, and if you can select the vessels, each ship vessels details will be popping up with the ship noise at the source level. Uh, Coming to the second layer, the bathymetry layer gives the ocean complete visualizations to user. So it will be helpful for user to visualize the ocean depth while selecting the area of interest that the user want to calculate the noise level for that particular region. Below that, you can see that a user can switch between the receivers frequency. Coming to the functionality of the area selection, so we are giving us the two user inputs option for area selection. So user can enter directly area of interest can south lat long coordinates can be put up manually, or just user can drag and select the area that you want to calculate the shipping related noise. So for that area selection, we also applied the different validations. So while selecting the area, for example, like if user selected the on land, so there is a restriction on selection of land. So that's the kind of validation is also applied for the area selection. And coming to the area selection calculation part, so area selection functionality gives the if for example I am selecting the region right now in the depths of the ocean. So accordingly, what is the available by considering the mathematic data of this area, it is giving us the depth arrays of values that can be select as a receiver's depth option. So that is the available depth right now. I select the more depth in the ocean, so you can select that the say to the up to the around 3,000 meters. So if, for example, right now, if I selected near the more where the coastal region, so you can see the difference between the depth receiver depth limitation. So right now you can only select with the 50 meters of depth. So that kind of validations and calculations are applied right now. So let's select one area and plot our noise mapping. So after selecting the area, as Sridhar sir also mentioned in the presentation that the H3 indices that we are using. So for the H3 indices lying in the area that is passing through the backend for the calculation, and after clicking on generating, it will be started the calculation of each for the each receiver point. So each H3 indices will act as a one receiver point, and the 200 kilometers area within the 200 kilometers of radius, whatever the vessels are pounding out. So for each vessel, it is calculating the transmission loss. So the transmission loss considering the different factors like what is the mathematical part or what is the reflection of the sound, what is this absorption due to the sediment. So that factor it is considering. So while it is computing, we can go ahead with previously calculated results. So I'm established different case scenarios that will showcase you the tool's capability and the accuracy of the tool. So first I'm selected the region in the low dense area, vessel traffic area. So you can right now see the diverse spectrum of the noise. The area, the shift far near to this area is giving this the noise range from the 90 decibels to 101 decibels, and the shift is far from this area is giving us the noise ranging from the 10 dB to 30 decibels. In terms of the second case of mediumly dense traffic zone, So you can see that the tool is calculating right now the results is between the 90 decibels to 120 decibels. But right now you can see the accuracy of the interpolation that we have done. So not is tool not giving us the directly based on the AI's location of the ship, but it's interpolating the according to the results. The third case, I select the scenario of a very high dense area. So right now, as I mentioned, if for each receiver points is calculating, and right now for each receiver, the 200-kilometer radius, in high density area, the ships found for each receiver is around 2,000 to 3,000 vessels, number of vessels. And for such heavy computations, also tool has the use capability of the computations. Fourth case I considered as near the coastal region with high density area. But right now you can see that there are lots of vessels, but the noise level bit I give is in a low spectrum. So the reason for that is if ships near the coastal regions are with lesser speeds, and also there is a sediment thing also there. So sediment absorption factor also rise in the sun. So that shows the accuracy of the tool. So it's still calculating. We can go ahead with the cumulative noise mapping thing. So cumulative noise mapping thing gives the uh, logarithmic sum of the noise level for the particular time period, and for based on the specific time period, specific based on the AI traffic for the specific time period. So it's taking some time to calculate. So similarly, you can see the logarithm. Same feature as the AI layer and mathematical layer as in the cumulative noise map also. You can select between the receiver's frequency also. There is an option of you can download all those your computed result in a PDF or image form, and you can reset all those layer in it, using the reset functionality. So coming to the final, this software is also available on cross-device device platform. So you can easily operate on the desktop, mobile, and tablet views also. It's taking a bit longer time to calculate. I should select the smaller region. So you can see that for each indices is going through the loop and calculating the transmission loss, considering all those factors. Yes, you can see the results right now. That the real time thing right now we have calculated. Yes, that's all from us. Thank you.